Hello. Let's tackle one more thing with conic sections. Actually, it's nothing new. This little section is just going to be a summary of conic sections. So it's just going to be repeating what you already know now, and it's going to be doing some more examples, just kind of in a generalized way so that you are ready to be able to tackle any equation, conic section equation that you come across. So that's what this is. So we've been talking about parabolas, circles, ellipses, hyperbolas. All of the conic sections have equations of the form all conic sections, including your parabolas, your circles, your ellipses, and your hyperbolas. Remember, they're called conic sections because if you intersect a cone with a plane, the cross sections have these shapes. But all of them have equations of the general form ax squared plus cy squared plus dx plus ey plus f equals 0, where a or c must be non-zero. So if you have your parabola, it'll have this format of the equation. Either a equals 0 or c equals 0, but not both. So if you think about what that means, if both a and c were 0, then you'd have dx plus ey plus f equals 0, which could be a line, which would be a line. So that's not a conic section. So you have one or the other. You have either an x squared or a y squared with the rest of that. But you can't have both of them, x squared and y squared, because then it's not a parabola. Then you're going into other territories. If you're dealing with a circle with this equation format, a equals c. So the numbers in front of x squared and y squared are going to be the same, but they also do not equal 0. So you have to have that x squared and y squared in there in order to have a circle. For an ellipse, a is not equal to c. And if you multiplied a and c together, that would be greater than 0. So an ellipse, unlike a circle, you'll have the x squared and y squared in there, but the numbers in front of those are different. And when you multiply those two numbers together, they have to be positive to be an ellipse. And then a hyperbola, kind of similar to an ellipse, but your AC is less than 0. So in other words, a and c, when you multiply them together, will be negative. And that's where that minus comes in that hyperbola formula. Okay, so that's the general form with these caveats for each conic section. So that's a nice little generalization. Now, you can have different situations depending on your sign. So make sure you are watching the sign, because that can make the difference, like with the ellipse versus the hyperbola. And it can also make the difference as to whether an equation even has a graph or is a conic section or not. Some of them deceptively at first look like conic sections, but once you work it out and try to get things into general forms, you'll see something's off with the sign or something's off with what it equals. So you'll be able to spot that, but just pay close attention. Okay, I'm going to this week sometime post a handout on Canvas that has all the different conic sections on it, but you can also look in your book page right currently in fall of 2021. Our book on pages 1026 to 1027 puts all the conic sections in the graph information together. So that might be something good to either photocopy and have for reference as you're doing your homework and studying or something. Or just be on the lookout in Canvas under modules. I will be posting a worksheet that's similar, has similar information. Okay, so let's do this. Let's start looking at some situations where we're thrown an equation and we have to determine, what kind of conic section are we working with and what would the graph look like. Okay, let's say we're given the equation x squared minus 4x plus y squared plus 2y equals negative 5. Okay, this looks a lot like that general form I just wrote earlier up there. In this case, a is 1, the d is negative 4, the c is 1, the e is 2, and the f would be 5. So it so far seems to fit that form. So let's see what we can do with it and narrow it down and see if it actually is a conic section or not. I mean, it's looking like it might be, but let's see for sure. So I'm looking at this and I'm spotting both an x squared and a y squared. And the numbers in front of x squared and y squared are the same. So that tells me I possibly have a circle here. Don't know for sure until I work it out, but it's a possibility. It's not an ellipse because you've got the a and c being the same number. The number in front of x squared and the number in front of y squared are the same. And they're not, at an ellipse they can't be the same. An hyperbola, that you have to multiply together and get a negative, so it's not either one of those two. And it can't be a parabola because in a parabola either a or c is 0 but not both. So you either have x squared or y squared but not both. So it's possibly a circle, but let's find out. All right, I want to get it into the circle format. Just a little reminder. That looks like, oops, sorry. That looks like x minus h quantity squared plus y minus k quantity squared equals r squared. Remember that formula for circles? So in order to get it there, I'm going to need to group my x's together and complete the square. And I'm going to need to group my y's together and complete the square. And since that's in the way, I'll move the negative 5 down there. All right, let's see. Half of 4 is 2, and then 2 squared is 4. So I'm going to have x squared minus 4x plus 4. But if I do that, I have to keep it balanced out. Since there's an equal sign, it's an equation, I have to keep it balanced out. If I add a 4 on the left, I got to add a 4 on the right. Then y squared plus 2y. Well, half of 2 is 1, and 1 squared is 1. So I'll add a 1 to that. But then I also got to add a 1 over there on the right. And you might, if you're quick in your head, you might already see a problem with this. Not on the left side. On the left side, we're able to factor. We've got 2 perfect square trinomials now because we completed the square. And first one factors into x minus 2 quantity squared, so into that binomial square. Second one factors into y plus 1 quantity squared, so that binomial square. But notice on the right, you might have already spotted it, we end up with 0. So it looks an awful lot like a circle, where the center would possibly be at 2, negative 1, but we can't have a radius of 0. So what we actually have here is a point. We have a point at 2, negative 1. And that's how we handle, that's what's happening when the radius is 0. It's not a circle, it's actually just a point. So if you want to graph it, you just graph a dot at 2, negative 1. And that's it. So that's why it looked kind of like it looked like a circle, but it turns out when we worked out the radius side, it wasn't. So just gotta keep an eye and make sure, follow things with signs, and then when you're completing the square, don't forget to keep things balanced and add things to both sides. Okay, let's do another one. So we're just throwing you these equations, and they don't look familiar yet, but we can start looking at what's in them to decide where this might be heading. So this next equation has an x squared and a y squared, but notice the numbers in front of the x squared and y squared are different. I don't want to jump yet and say, I don't want to say yet what a times c is until I move the y squared over to be with the x squared. So I'm going to rewrite this as 9x squared plus 16y squared. I'm going to go ahead and leave it as equals 144. And this is looking strongly like it might be an ellipse, because the a and c, 9 and 16, they're different, and they multiply and give you something positive. So let's do that last step of dividing everything through by 144 and seeing what that gives us. Let's see, so we'll have x squared over 16 plus y squared over 9 equals 1. Awesome. That does give us an ellipse. And it's centered at 0, 0. So like if we want to graph this ellipse, the horizontal axis, the center's at 0, 0. Horizontal axis is going to have to go out to 4, negative 4. Because underneath x squared you have 16, and then the square root of that is 4. And then the vertical axis is going to have to go up to 3 and down to negative 3. Because if you look underneath the y squared, you have a 9, and the square root of that is 3. And then you can draw your little elliptical shape. There you go. So that worked out nicely. Looks less like an ellipse and more like a lemon or something. Drawing these is hard, especially on a tablet. Okay, let's do another one. 2x plus y squared minus 10y plus 17 equals 0. All right, I'm spotting a y squared, but not an x squared. So that's telling me this is probably a parabola. So for the parabola, I'm going to get the x over on one side. Because in this case, I'm dealing with y squared, so I'm going to have to work on that some. And for the y squared, leave myself some space here. I'm going to group together the y squared minus 10y, because I want this to be in the standard parabola form. And I already see, too, that this is going to be a parabola that either opens left or opens right, based on the fact that it's y squared and not x squared. So that's a wealth of information there. And since it's y squared, I'm aiming to get it into that format where you have the x minus h equals a times y minus k squared. So, actually, if I'm going to get it in that format, maybe I should go ahead and move the 17 over too. I mean, either way, if you subtract the 17, I'll go ahead and subtract the 17 also from both sides. You could leave it on the left side. It's up to you what you're more comfortable doing. All right, so half of 10 is 5. 5 squared is 25. So adding 25 here, there's nothing in front. So let's go ahead and add 25 over here as well. So we've got y minus 5 squared equals negative 2x plus 8. If I need that a, So I'm going to go ahead and factor a negative 2 out on the right. And then I'm going to divide both sides by negative 2. So I end up with negative 1/2 times y minus 5 squared equals x minus 4. Okay. So this tells me that I have a parabola with vertex at 4, 5. The h, k is the vertex. Then since a is negative 1/2, which is less than 0, that tells me that this parabola is going to open up to the left. All right, so let's get graphing. So I'm going to need 4, 5. Let's use 8. 8, 7, 6, 5, 4, 3, 2, 1, 0. I don't think I need anything below that. 1, 2, 3, 4, 5, 6. I don't need anything further than that. Okay, so 4, 5 goes right here. That's my vertex. And if I do a little XY table, I already have 4 and 5. If I want to get back, if I plug in 3 for y, I'm going to get at 2 for x. And also if I plug in, I think it's 7 for y. Yes, for negative 2. Yeah, I also get 2 for x. So 2, 3, 2, 7. So there we go. So there's my parabola. And then it has that horizontal axis of symmetry. So the horizontal axis of symmetry and you get y equals 5 for that, because it's halfway between your 7 and your 3. So 5. Or it's through the vertex, 4, 5. So that y coordinate of the vertex tells you where your horizontal axis of symmetry is going through. But there you go. So yes, that turned out to be a lovely parabola. Okay, got a couple more where these came from. Just wanted to do lots of examples for this summary. Negative 4x squared minus 24x plus 25y squared plus 100y equals 36. All right, I know it's not a parabola because I see an x squared and a y squared. It could either be an ellipse or a hyperbola, possibly, because there's different numbers in front of x squared and y squared. So I'm going to start that process of trying to get it into a standard form. Whether it's ellipse or hyperbola, the process is the same. So let's group together the x's. Let's group together the y's. And then factor first. So factor out negative 4 from the x's. Leave a little space because we're going to need to complete the square. Factor out 25 from the y's. Again, leave a little space because we have to complete the square. And all that equals 36. All right, half of 6 is 3. 3 squared is 9. So I can put a plus 9 in that first set of parentheses. But notice I'm not actually adding 9 on the left side. I'm actually adding a negative 36 because of that negative 4 that had been factored out. So over on the right, I need to do a minus 36 as well. Then for the y's, half of 4 is 2. 2 squared is 4. So that's plus 4 in the parentheses. But I'm not actually adding 4. I'm adding 4 times 25, which is 100. So plus 100 on the right side. All right, so I got -4 parentheses x plus 3 squared. So that's the factorization of that perfect square trinomial. Plus 25 times y plus 2 squared equals 100. Yeah, I'm thinking this is going to be a hyperbola. Because -4 and plus 25, they're going to end up with that negative sign that we need for classic hyperbolas. So I think that's where we're heading. All right, divide through by 100. Finish it up before we can be for sure. Let's see, so we end up with negative x plus 3 squared over 25 plus y plus 2 squared over 4 equals 1. Okay, I'm not comfortable with having that negative first because of the way hyperbolas are written. So I'm going to write y plus 2 squared over 4 minus x plus 3 squared over 25 equals 1. So now it looks the way I'm used to with the hyperbolas. And so we already dealing with a hyperbola. And since that first fraction has the y and the second fraction has the x, we know that the parts are going to open up and open down. Okay, so underneath y plus 2 squared is a 4. So we're going to need to use 2 for that. We're going to have a is 2, and then we're going to have b is 5. But we also have to think about where's the center of this thing. Okay, so the center, you have x plus 3, so the x-coordinate of the center is going to be -3. And you have y plus 2, so the y-coordinate is going to be -2. Okay, let's plot that center and go from there. -3, -2 is right here. Draw me some more little marks on my axes so I can count. Each one just represents a unit. Okay, so a is 2. That's along the y. That's along the vertical axis. So from the center, we need to be able to go up 2 and down 2. And that's actually going to be my vertices. So we have a vertical transverse axis. So we're dealing with that. So that tells me which way the little curves are going to go. So then I also need to deal with B. B is 5. So from the center, I need to go 5 right. 1, 2, 3, 4, 5. And 5 left. 1, 2, 3, 4, 5. And that'll give me the information for drawing my lovely rectangle. And remember, that rectangle is just a tool. It's not officially part of the graph. But that rectangle helps me to recognize where the asymptotes are going to go. Oh, sorry about that. Oh. From the center. I did not figure out what the y-intercepts were there. So I don't know how accurate that is. I'm just sketching my asymptotes. But then now I can draw my lovely curves. These are pretty spread out. And there you have it. So there's my hyperbola. That looks lovely. I like to sit back and kind of take it in and enjoy it for a minute. And just visually like look it over and make sure everything looks okay. Try to spot any mistakes that might have happened. But it looks all right. So there you go. Okay, let's tackle one more equation and then we'll do a little summary on geometric definition of a conic section having to do with eccentricity. Okay, so let's do one more. 9x squared minus 72x plus 25y squared minus 100y equals negative 19. Definitely not a parabola, because I have both an x squared and a y squared. And I'm thinking not a circle, because a and c are different. In front of x squared is a 9, in front of y squared is a 25. Possibly either an ellipse or a hyperbola. But let's do our process. Let's work it out, see what happens. So 9x squared minus 72x, we'll group that together. And 25y squared minus 100y, we'll group that together. And I know it equals negative 19 right now, but remember, as we complete the square, we'll add stuff over there that'll change that'll probably change that value. Okay, let's factor out a 9 from the x's and then leave ourselves a little room. And let's factor 25 from the y's. And again, leave ourselves a little room. That still equals negative 19. All right, in the x's, half of 8 is 4. 4 squared is 16. So let's add 16 in the parentheses. But we're not really adding 16. We're adding 16 times 9, which is 144. So let's add 144 over here on the right to keep it balanced. Then for the y's, half of 4 is 2. 2 squared is 4, so plus 4. But we're not really adding 4. We're adding 4 times 25, which is 100. So let's add 100 on the right to keep it balanced. So factor. We got 9 times x minus 4 quantity squared plus 25 times y minus 2 quantity squared equals, and then if you add negative 19 plus 144 plus 100, you get 225. We're going to divide everything through by 225. So we end up with x minus 4 squared over 25 plus y minus 2 squared over 9 equals 1. All right, we are dealing with an ellipse because we have that plus sign in there in the equation. The x's and y's were different. We had x squared and y squared. The numbers in front of them were different. They're positive. 9 times 25 is a positive number. And when we finish working it out, we definitely have the equation of an ellipse. So let's graph it. So it's an ellipse. And the center is at 4, 2. We're just trying to sketch the graph. You know what? I'm going to go ahead and go by ones. Why not? I got enough space. All right, so I plotted 4 comma 2 for my center. Underneath the x minus 4 squared is a 25. So square root of that is 5, which means you can go right 5 from the center, and I can go left 5 from the center. So I end up with the points 9 comma 2 and negative 1 comma 2 from the center 4 comma 2. So that's it's on the, from that, those points are all on the same horizontal line. So the y coordinate stayed the same. It's 2 for all of those. But notice, since you're dealing with 5 there, 4 minus 5 gave you one x coordinate, and 4 plus 5 gave you the other. All right, and then under the y's we have a 9, so we take the square root of that and get 3. So from the center, we have to go up 3. X coordinate is the same. Y coordinate is 2 plus 3, or 5. Then we got to go down 3 from the center. X coordinate is the same. Y coordinate is 2 minus 3, which is negative 1. And now I've got everything I need to draw my lovely ellipse. Well, there you go. Okay, let's wrap this up with a quick summary on eccentricity. In your book, they say it's the geometric definition of a conic section. All right, so you have a fixed point F. That's the focus. It's one of the things you're given. You also are given fixed line L. That's your directrix. And a positive number E. Remember, this E is not like the E you have in financial formulas, the 2.4, etc. This is E for eccentricity. So for the definition, the set of all points P so remember, P is just generic for any point that makes up your parabola, or any point that makes up your ellipse, or any point that makes up your hyperbola. So all those points that make up your conic section in the plane such that distance of P from F, so distance of any point on your conic section from your focus, equals E times distance of P from L. So you're looking at that ratio. Is a conic section of eccentricity E. So if you solve for E, the distance of P from F over the distance of P from L would be your eccentricity. When E equals 1, you have a parabola. When 0 is less than E less than 1, you have an ellipse. And when E is greater than 1, you have a hyperbola. So we went over that in all the other videos, in a couple of the other videos on conic sections. But this is just a summary of, giving you the definition, the official definition. But we already talked about how the eccentricity when it's 1 is a parabola, and then for an ellipse between 0 and 1, and then greater than 1 for hyperbola. And that's the note that the lesson ends on. All right, so again, keep an eye out pretty soon. If you don't spot it, like if you're watching this video and you don't see it there yet, send me a message. But the next day or two, I'm going to be posting a file under modules that has all the conic sections and formulas and all that to help summarize it so that you can use that as a reference while you're trying to study. Okay, well, thank you for joining me. That's all I have to say about conic sections for this course, for this pre-calc course. When you join me again, we're going to be doing something quite different, but pretty fun. So I don't want to say too much more than that because I want you to, tune in. So I'll see you again soon.